Hi everyone, welcome to today's presentation which is about derivatives. So in this lecture we will learn derivative as a slope of tangent line. So derivative as a slope of tangent line. So let's suppose we have a xy plane where this is x-axis and this is y-axis and this is the origin, and we are given a function y is equals to f of x, and let this straight line as the graph of this function y is equals to f of x. Now if we want to find the slope of this straight line, then what is the slope of this straight line or this curve? Slope is equals to rise over run, where this is the rise, which is delta y, and this is the run, which is delta x. We can also write it as change in y. Rise is also known as change in y, and run is known as change in x, where change in y is delta y and change in x is delta x. So this is the slope of that straight line, which is denoted by m. So the slope of the straight line is change in y over change in x. Now, as this is a straight line, therefore the slope at every point of this straight line is the same. Slope is not changing. The slope will remain the same at every point of this straight line, as this is a straight line. Therefore, the slope is not changing. Now, if we have an xy plane, this is x-axis and y-axis and origin, and we are given a function y is equals to x square, and graph of the function is a curved graph. This is a curved graph. Now, how how to figure out the slope of this curve? How can we figure out the slope of this curve, as the slope is keep on changing for the entire curve, as this is the graph is a curved graph. This is not a straight line, this is a curved line. Therefore the slope is keep on changing on the entire curve. So how can we find the slope of this curve? But we can try to find the slope at the point P of the curve, like this is the point P and this is the tangent line at this point P, as this is a straight line and this line is touching the graph at just one point. So the slope at point P, the slope of the curve at point P is equals to the slope of the curve of the tangent line that is passing through point P. So the slope of the curve at point P is equals to the slope of the tangent line through P. This is the tangent line, and the slope of this tangent line is equals to the slope of the curve at point P. Similarly, at point Q, the slope is same as the slope of the tangent line at Q. Similarly, at point R, and this is the point T, we can find the slope of the curve at these particular points Q, P, R, and T, but we cannot find the slope of the whole curve. So, how can we figure out what is the slope of the curve? We can find the slope at particular points by the finding the slope of the tangent line, but we cannot find the slope of the whole curve. So how can we figure out what is the slope along the curve? That's where the derivative come into use. This is the point where derivative come into use. And now you will understand that why limit is a useful concept. So at this point, you will understand what is the need of limit in our life. So the limit at some point A, we know that the slope of the equation at some point is defined as f of a plus h minus f of a whole divided by h. This is where derivative come into being. Limit h approaches to 0, f of a plus f of h, f of a plus h minus f of a whole divided by h. This is equals to the derivative of a function at the particular point A. And derivative, now we will write the definition of derivative. Derivative as a slope of the tangent line is the derivative of a function, the derivative of a function f at a number a is denoted by f prime of a. The derivative of a function f at a number a is denoted by f prime of a, and it is defined as f prime of a is equals to limit h approaches to 0, f of a plus h minus f of a over h. This is the derivative. This is how the derivatives are defined. If the limit exists, remember, if the limit exists, then the derivative exists. So the derivative of a function f at a number a is denoted by f prime of a, and it is defined as f prime of a is equals to limit h approaches to 0, f of a plus h minus f of a over h if the limit exists. Provided that the limit exists, then the derivative exists. So this is how we define the derivative of a function as the slope of the tangent line. The derivative of a function f at some particular point A has a slope of tangent line. We can also write the definition in another way, that if we write x is equals to a plus h, then x minus a is equals to h. So, and h approaches to 0 if and only if x approaches to a. If we define x as a plus h, then x minus a is equals to h, and h approaches to 0 if and only if x approaches to a. When x will approach to a, then h approach to 0. So the derivative of the function f at point A will become limit x approaches to a f of x minus f of a over x minus a. This is the another notation for the derivative of a function at point a. This is the point. This is the first definition, and this one is the second definition as we defined the h. X is equals to a plus h. If you remember uh, that that definition of the tangent line, that in an xy plane, this is the curve of any function. This is the point P and Q. We drive or we make a secant line, and we want to find the slope of that secant line. If the slope approaches to some number m, then this is the if the slope approaches to some number m, then we say that the tangent at point P exists. And how the number will approach to m if we let Q approach to P along the curve. And how Q will approach to P when we let the number A approach to X, then the point Q will approach to P, and we will say that the slope of that secant line is equals to the slope of the tangent line at point P. So this was the concept of uh, the tangent line. So the derivative of the function f at point A is equals to limit x approaches to a f of x minus f of a over x minus a, and other way. And this was the first definition, and this is the second definition of the derivative of a function as the slope of tangent line. Now we will do some exercise. We will apply the definitions to find the derivative. So the question here is, find the derivative of a function, the derivative of a function where the function is f of x is equals to x square minus 8x plus 9 at some number a. So what we have to do, we have to find the derivative of the given function at some particular number a. So the solution is f of x is equals to x square minus 8x plus 9. We have to find the derivative at a particular number a. So this is our aim. We have to find the derivative of the given function at some point a. So we know that f prime of a is equals to limit h approaches to 0 f of a plus h minus f of a over h. So f of x is given. We will put a plus h in the place of x. So f of a plus h is equals to a plus h whole square minus 8 into a plus h plus 9. This is f of a plus h, and f of a is equals to a square minus 8a plus 9. Now we will put these two values in the given function in the definition. I should rotate the page so that you, so the limit f prime of a is equals to limit h approaches to 0 f of a plus h, and f of a plus h is equals to a plus h whole square minus a plus 8a plus h plus 9 minus f of a, which is equals to a square minus 8a plus 9 whole divided by h. Now we will simplify it to get more simpler form of the equation. So limit h approaches to 0 is equals to, open the formula, it is a square plus 2ah plus h square minus 8a minus 8h plus 9 minus a square minus 8a and minus plus minus minus 9 all divided by h. Now we will cancel some of the values, a square with minus a square and 8a with minus 8a and 9 with minus 9. So limit h approaches to 0 is equals to 2ah plus h square minus 8h all divided by h. Now the limit h approaches to 0, we will take h common and it will become h into 2a plus h minus 8 whole divided by h. Now we will cancel this h with each other. So what we get the simpler form of that equation, which is equals to 2a plus h minus 8. Now we will just apply the limit and it will become 2a plus 0 minus 8. So what we get 2a minus 8. This is the derivative of the given function. This was the function. We want to find the derivative at point A. So this is the derivative of that function at point A. Let's say A is equals to 2, then we will put 2 in the place of A. It will become 4 minus 8, which is equals to minus 4. So this is the derivative of that function at point A. If A is equals to 2, then the derivative is equals to minus 4. So this is how we can find the derivative of a function at the particular point A. Now we come to the point that the tangent line to y is equals to f of x at a f of a is the line through P whose slope is equals to f prime of a, which is the derivative of a function at a. So from the previous lecture, through what we have learned in the lecture, that the slope of the curve at the particular point P is the slope of the curve, which is the derivative of the function at the given point P. So we come to the point that the tangent line to the given function or equation y is equals to f of x at point a f of a is the line through point P the line through whose slope is equals to f prime of a, which is the derivative of the function f at a. So the tangent line to equation y is equals to f of x at point a is a f of a is the line through point P. This is the point P whose slope is equals to f prime of a, the derivative of function at a. this is the graph of the curve. This is the curve, and this is the point P. The slope of the curve at point P is equals to the slope of the tangent line at point P. If this is the tangent line, then the slope of the curve is equals to the slope of the tangent line, which is the derivative of the function. This is y is equals to f of x, and this is the point A f of A. Then the line through point P, A f of A, this is the point P whose slope is equals to f prime of A. So the derivative, the definition of the tangent, slope of the tangent line is equals to the definition of the derivative of a function at some given point. This is the definition of the slope of the tangent line, and this is the definition of the derivative at some certain points. So we get that the tangent line to y is equals to f of x at a f of A is the line through point P. This is point P, a f of A, whose slope is equals to f prime of A, the derivative of a function at point A. Now we will do some question. We will do some more question. So the question here is to find the derivative of a function f prime of A, derivative of function at point A, and f of x is given where f of x is equals to 3x square minus 4x plus 1. This is the function. This is the given function. We have to find the derivative at point A. So the derivative at point A is equals to limit h approaches to 0, f of A plus h minus f of A over h. F of A is equals to 3a square minus 4a plus 1, and f of A plus h is equals to 3 into a plus h whole square minus 4 into a plus h plus 1. And if we simplify it, it will become 3a square plus 3h square plus 6ah minus 4a minus 4h plus 1. So this is the expression we get. Now we will put these two values in the given definition, in the definition of the derivative. So let's rotate the page and do the question. So f prime of A is equals to limit h approaches to 0. F of A plus h is 3a square plus a 3h square plus 6ah minus 4a minus 4h plus 1. This is f of A plus h, and minus f of A is minus 3a square minus 4a plus 1. Minus 4a plus 1 whole divided by h. Now we will simplify it. We will cut 3a square with minus 3a square, 4ah with minus 4ah plus 1 with minus 1. So what we get 3a square plus 6ah minus 4h divided by h, where limit h approaches to 0. Now h We will take h common, and what we get 3h plus 6a minus 4 over h. This h is cancelled with the h where limit h approaches to 0. Now what we get? We get 3h plus 6a minus 4. Now we will apply the limit easily. It will become 3 into 0 plus 6a minus 4, and this is 6a minus 4. This is the derivative of the function at the point A. This is the derivative of the given function at point A. This is how we can find the derivative of a function. So this is enough for today. In our lecture, we have learned what are derivative as the slope of the tangent line.